Hi everyone, in this video we're going to be talking about section 5.6 and this is the half-angle identities for our trig functions. Okay, so we're going to start finding our half-angle identities, and in order to find these we have to use our double angle formulas that we learned in the previous section. So if you haven't learned about those yet, I would recommend going back and watching the 5.5 video about double angle identities. So we're going to start with the cosine double angle identity, cosine 2x. If you recall, we had three versions of what cosine 2x could equal. And so we're going to use one out of our three versions right here on the left side and find our first half angle identity. So we're going to solve this equation for cosine x. So start by adding 1 to both sides, and then we'll divide out the 2. And then we're going to square root both sides, keeping our plus and minus. So when you take the square root, add the plus and minus in. And now we're just going to adjust our angle or argument here. Instead of it having a 2x in here, we're going to make this just x, or in this case we're going to call it a, and that's going to affect what we end up having outside here. And so if you let 2x equal the letter a, or you can call it angle a, then what you have is a half angle identity. So cosine of a over 2, or half of angle a, equals this quantity. Now, just again real quick, this is for if you have an angle A, but you want half of it, half of that angle, and then the cosine value of half of that angle A. So this is our first half angle identity. We're going to do the very same process with our other or alternate double angle formula for cosine, and then we'll solve for sine x. So same process as the last one. And then when we take the square root, we'll replace 2x with a, giving us our next half angle identity or formula. So sine of half of a, or a over 2, equals this quantity. And so you actually have to choose which plus or minus you're going to use, either positive or negative, depending on which quadrant this angle is in. So we'll do an example where we figure out which quadrant, and so therefore which sign plus or minus to use. Now our half angle identity for tangent, there's actually 3 of them. So tangent of half of an angle, or a over 2, the first version of it, just requires that we have our two results that we just found, sine of a over 2 divided by cosine of a over 2, since tangent is the quotient of sine over cosine. We fill in those quantities and then simplify to get our first version of tangent of a over 2. The second version, this one, it starts the same way. We divide sine a over 2 divided by cosine a over 2, but then we do a little bit of manipulation. From this step to the next step, we multiply by cosine a over 2, top and bottom. And then what that allows us to do is rewrite using our double angle identities the next step, giving us a second version for tangent a over 2, which is sine a on top, 1 plus cosine a on bottom. And then a similar process will get us our last version for tangent of a over 2. So here are our 5 half angle identities, 1 for cosine, 1 for sine, and then 3 for tangent. Okay, so if you know your double angle formulas, that's how you can quickly come up with your half angle formulas. For this first example, we're going to find the exact value of cosine 15 degrees by using a half angle identity. Now, if you think about the exact value, we don't know the exact value of cosine 15. It's not one of the familiar ones that we have on our unit circle. And if you type this in your calculator, it's going to give you some decimal approximation. So we're going to use our half angle identity, and 15 degrees, if you look at your formula here, your identity, cosine of 15 degrees is actually half of some angle A. And then inside the formula, you need cosine of the angle A. So you just have to think about, well, okay, 15 is half of the angle I'm looking for, so that means we're actually interested in cosine of 30 degrees. So half of 30 degrees is in fact 15, and then in our formula, we're going to put a 30 where there's an A. So we get 1 plus cosine 30 degrees over 2. And then we pick this positive, notice there's a plus and minus here. We pick the positive square root because 15 degrees is in quadrant 1 and cosine is positive in quadrant 1. All right, and then we knew the exact value of cosine 30 degrees, it is square root 3 over 2. And we'll just simplify this answer to make it look a little bit nicer. So multiply top and bottom by 2. And then we end up getting on top square root 2 plus square root 3. Notice the square root 3 is actually inside the previous square root. And then all over 2. Let's try this one. We're going to find the exact value of tangent 22.5 degrees using our half-angle formula for tangent. Remember, we had 3 versions here, but we're told to use this version. And so think about this value, tangent of 22.5. This is half of the angle we want. So you can just think about doubling that. And 22.5 is half of 45. Just times 22.5 by 2. And that's how you can come up with 45. And so A is the full angle. 22.5 was half of it. So where we have an A in our formula is going to get replaced with 45 degrees. And then we know these exact values from our unit circle. And we fill those in. And then we just simplify. So this is the answer here, but it's not very nice looking. So let's simplify. All right, so we're going to multiply top and bottom of this fraction by 2. Okay. Then we end up with root 2 on top, 2 plus root 2 on bottom. Let's keep simplifying. So at this point, we're just going to rationalize the denominator. It has 2 terms in it, so we're going to rationalize by multiplying by the conjugate. So that just means since there was a plus sign here in this 2-term denominator, we make it a minus sign, and then FOIL out the top and bottom. We'll distribute on top, and then FOIL the bottom. And feel free to pause it if you want to work this out. You end up with root 2 minus 2 on top, and then 4 minus 2 on bottom. And again, that was from FOILing out the bottom. And then you can actually factor out a 2 from the top, and it divides with the 2 on bottom. For our final answer, square root 2 minus 1. Let's try this example here. So we're given cosine of s. Think of s as your angle. So cosine of s is 2/3. And then we're actually told which quadrant that s is in. And then we're asked to find all these half angle values. So cosine of half of s, sine of half of s, and tangent of half of s. Well, we don't actually know what the angle s is, and we don't need to know it. We just are going to use this fact that we're given that cosine s is 2/3, and we'll use our half angle formulas. Let's start with figuring out which quadrant half of s would be in. So we're told that s is between 3 pi over 2 and 2 pi, which is quadrant 4. Okay, so let's take half of that. So if we divide the lower value, the lower end, s, and the upper end here by 2, it's going to tell us where half of s is at. All right, so in the middle, focus on the middle here, s over 2 is half of our angle. And now notice its boundaries. It's greater than 3 pi over 4, but less than pi. So that would actually put us in quadrant 2. Okay, so half of our angle lies in quadrant 2, and that's just going to help us figure out the plus or minus signs for our answers. So in quadrant 2, sine is going to be positive, but cosine and tangent are going to both be negative. So we'll just use that to pick the right plus or minus when we use our formulas. So let's start with sine of half of our angle s. Okay, so notice we already started with picking the positive. I don't have a plus and minus here. We already know it's going to be positive, so I just leave it positive. We were given what cosine s equals, so we just plug that right into our equation, right into our formula. So technically this is the answer, but let's make this look a little bit nicer. And after we simplify somewhat, common denominator, and then you're dividing a fraction here, so flip and multiply. We end up with square root 6 on top, 6 on bottom, after rationalizing. Okay, let's try to find cosine s over 2, cosine of half of s. We already figured out it should be negative. And same thing like we just did, we already were given cosine s, so fill that in. And then simplify, just like we did on the last one. We end up with, after rationalizing, negative root 30 on top over 6. And then tangent of half of s, or s over 2, we can use our 2 values that we already figured out since tangent is sine over cosine. So we're just going to divide our first 2 answers. and then simplify. Okay, so flip and multiply, and we end up with, after rationalizing and simplifying, negative square root 5 on top and 5 on bottom. In this example, we're just going to simplify the expressions. Now, before I show you how to do this one, just kind of look at the first one, part A, and hopefully it looks familiar based on what we've talked about so far. This looks like one of our formulas, and I'll remind you which one. It is the cosine half-angle formula. Okay, and the reason why is because it had the plus sign. It is very much similar to our sine of a over 2 identity, but that one had a minus sign. So this one we pick because it has 1 plus cosine A over 2 inside the square root. Okay, so we basically just have to make what we have match with our formula here. And so where we had a cosine A in our actual expression, we have a 12x, cosine 12x. So we just substitute that in. We have plus and minus our square root is just equal to cosine 12x over 2. So all we did here was recognize that cosine was of 12x, so the 12x took the place of a. So it's cosine 12x over 2. Final answer, cosine 6x. All right, the next one, if you look back at your formulas, this looks very much like our half angle for tangent formula, one of the three. And so this one lines up very quickly, just like our last example, just recognizing what a should be. So 1 minus cosine 5 alpha over sine 5 alpha. A is just 5 alpha. So it's just going to go right in this spot right here. So this is tangent of 5 alpha over 2. So in this last example, we're going to verify this identity. And with any identity, you want to work with the more complicated side usually to start. It just makes it easier because you have more to work with. So for us, that will look like the left side. So notice what you have on the left side. You actually have a binomial. You have two terms getting added here, and then the quantity is being squared. So we're going to FOIL out the left side. So feel free to pause this and work this out. And you're FOILing this out. You're doing a binomial times itself. So you're going to end up with 4 terms. All right, after you FOIL, you have a sine squared x over 2. You have a total of, if you add up the two middle terms, 2 sine x over 2 times cosine x over 2, and then plus cosine squared x over 2 in the back. So there was 4 terms, but the 2 terms in the middle added up to this middle term after you FOILed. All right, now we just want to eventually get to 1 plus sine x. That's our goal because that's the right side of the equation. So we have to simplify this quite a bit and use the formulas that we've learned so far and see if they apply here. All right, so next step, just rearrange, and you'll see why. So I'm just taking the sine squared x over 2 plus cosine squared x over 2 and putting it together in the front here. Hopefully this looks familiar. I'll give you a hint. Just think of this as theta. Sine squared theta plus cosine squared theta. All right, so that's our Pythagorean identity right there in the parentheses. This also hopefully looks a little familiar. This is your double angle formula for sine. Just replacing the thetas with x over 2. Okay, so we're going to use both of these equations, both of these previously learned identities to simplify what we're working with. And so the parentheses just becomes 1. And then this 2 sine x over 2 times cosine x over 2 just becomes sine 2 times x over 2, where theta is x over 2. So right here in our formula, you're just replacing theta with x over 2. That's why it's 2 times x over 2. And then the 2's divide out. Final answer, 1 plus sine x was exactly what we were trying to find, so we did in fact verify this identity.